So in the previous video we saw that how the valencies are there for a radical, and we need to know the valency chart. So the next part is how, so what we have learned up till now is we have learned the ABCD of the chemistry. Okay, symbols learn कर दिए, उसका valencies learn कर दिया. Now it's the time to make 2-letter, 3-letter words. GO, GO, TO2, AT, तो वो सब बनाने का भी टाइम आ गया for chemistry. So सोडियम क्लोराइड, सोडियम लेंगे, क्लोरीन लेंगे, NaCl. So how do we form this thing? Now before that, in the next page you are given the periodic table showing the elements of atoms from 1 to 20. So it is seen the periodic table is basically a table which is going to be placing the elements in it so that all the elements which are there in the same vertical line, they will be having similar properties, and that properties are similar because they have got the same valency. Like you can see, hydrogen, lithium, sodium and potassium are in the first line. Hydrogen has got 1 plus as the valency. Lithium 2, 1, that is also plus 1 valency. Sodium 2, 8, 1, again plus 1 as the valency. Potassium 2, 8, 1, again plus 1 as the valency. So you can see that the periodic table helps you to group all the elements of the same valency together so that they will be having similar properties. So what we are going to study over here will be only the first 20 elements which are there. We already studied the electronic configuration of the first 20 elements in the atomic structure chapter. So we already know that what is the different valencies over here. So the same chart is very much given over here once again, what we learned in the atomic structure ka chapter. So we have hydrogen, which is atomic number 1, so it has got only K shell where it is got 1 electron, and that's why the valency is plus or minus 1, and it will be considered to be as a non-metal as well as a metal because it can be used as both the purposes. Helium is going to be 2 atomic He, which will be 2 is the atomic number, and that's why it will be having just K shell having 2 electrons, and it's a noble gas because valency is 0. Lithium is the atomic number is 3, so it is 2, 1, so it is plus 1 valency, it's a metal. Beryllium will be 2, 2, so plus 2 will be the valency, so again a metal. Boron is B, which is 2, 3, which is plus 3 as the valency, but it's a special number which is a metalloid because it has got property of both metals and non-metals, that's why it is called as a metalloid. Carbon is 2, 4, it is a non-metal with 4 as a valency. Nitrogen 2, 5, minus 3 as the valency because it requires 3 electrons to complete its one outermost orbit, that's why the valency is minus 3, it's a non-metal. Oxygen 2, 6, so minus 2 is the valency, non-metal. Fluorine is 2, 7, so minus 1 is the valency, it will be a non-metal. Then comes neon, which will be 2, 8, which will be valency 0, hence it is a noble gas. We move to sodium. Sodium is 2, 8, 1, again plus 1 will be the valency, so it's a metal. Magnesium will be 2, 8, 2, though it will be plus 2 will be the valency, that's why it will be a metal. Aluminum will be 2, 8, 3, so it will be plus 3 as the valency, it will be a metal. Silicon will be 2, 8, 4, so 4 will be the valency, it will be a metalloid. So silicon is a metalloid. Phosphorus is 2, 8, 5, it has got double valency, 3 as well as 5 because of its special kind of a structure. So 2 and 5 are, it's a non-metal with having the valency 2 as well as 5. Sulfur is 2, 8, 6, which will be having valency equal to 2, it's a non-metal. Chlorine is 17, that is 2, 8, 7, so that is minus 1 as a valency and it's a non-metal. Then argon is 2, 8, 8, so its valency is 0 because outermost orbit is completed, hence it's a noble gas. Potassium is 2, 8, 1, So plus 1 will be the valency and the metal, it will be a metal. And finally is calcium is 2, 8, 8, 2, which will be plus 2 as the valency, and hence it's a metal. So this is what is there in the case of the electronic configurations के हिसाब से what is the valency of the metals of the first 20 elements of the periodic table, that is from atomic number 1 to atomic number 20. Now we'll see how we are going to frame the names, or you can say frame the symbols of the compounds. Now for this, what I'll do is I'll just write down certain valencies over here. So let's write it down. So it's over here, potassium is K1 plus, sodium is Na1 plus, ammonium it is NH4 1 plus. We'll take 3-4 examples just for our sake. So it is copper 1, that is Cu1 plus, or we can say copper 2, which will be Cu2 plus. We can have iron 2, which will be Fe2 plus, and iron 3 as Fe3 plus. We'll just stop over here. And next we will be having some negative radicals. So some negative radicals we can have over here as first is chloride, which is Cl1 minus. We can have another one as oxide. Okay, we'll take oxide, which is 2 minus. Oxide, which is O2 minus. We have got hydroxide, which is OH1 minus. We will take carbonate. Okay, carbonate is CO3 2 minus. Okay, carbonate. Let's take we'll take sulphide S2 minus, sulphite SO3 2 minus, and sulfate SO4 2 minus. I think these are sufficient for our example to understand the different naming. So in this case, what we are going to do is, of course, we have learned this thing. Okay, this is something, the page I told you, page number 49, very very important. You need to learn by heart completely. So now you know this page completely by heart. Now let's suppose that I have got a particular name as sodium chloride. The name of the compound is sodium chloride. I need to find out that what should be the symbol of this particular compound. So what I'm going to do is a simple thing. I'm going to write the symbol of sodium. What is the symbol of sodium? It's Na. And below it, I'm going to write the valency of this. The valency of sodium is 1 plus. So I'm just going to write 1 over here. Okay. Chlorine is Cl. And I'm going to write the valency as 1 over here. Then what we do is cross multiply. Okay. So on cross multiplication, what happens? Na1 and Cl1. So the name is NaCl. The symbol for sodium chloride is NaCl. Got it? Let's take another example. We'll take the example now of sodium hydroxide. Okay, I'll not say hydroxide, I'll take it as something different. I'll take it as sodium carbonate. Sodium क्या है? It's Na. What is the valency? It's 1. What is carbonate? It's CO3. What is the valency? It's 2. So you cross multiply. You get over here Na2CO3. Understood? So sodium carbonate will be Na2CO3. It will not be NaCO3. Why is it so? Because carbonate has got, carbonate has got valency 2, means it requires 2 electrons. Carbonate has got valency 2 minus, that means it requires 2 electrons to complete to become stable. Whereas sodium can give only 1. तो कार्बोनेट क्या बोलेगा? भाई मुझे तो 2 चाहिए. सोडियम में मेरे पास तो एक ही है. तो कार्बोनेट ने क्या बोला, एक काम करना और एक अपने फ्रेंड को लेके आ, उसको बोल मुझे देने के लिए, हम लोग तीनों साथ में जाएंगे. So what will happen? 2 sodium atoms will combine with 1 carbonate radical to form a compound sodium carbonate. समझ में आया? So this way the formation of a compound takes place. Let's take another example over here. So we'll first read this thing and then take some examples. It is chemical formula, the term, it is representation of the substance by means of symbols. It denotes in a compound the number of atoms of each element present. So that is very important. The name of the compound over here, the symbol of the compound, it tells me that how many sodium atoms, how many carbon atoms and how many oxygen atoms are present in this particular compound sodium carbonate. It will tell me that there are 2 sodium atoms, 1 carbon atom and 3 oxygen atoms present in sodium carbonate to form into a compound. No doubt, the calcium, carbon and oxygen are already combined in the form of a radical, but still I will know that how many different elements or different atoms of the elements are present in that compound. So substance, sodium chloride, symbol is Na for sodium, Cl for chlorine. So number of atoms of each present is 1 atom of Na and 1 atom of chlorine. So the chemical formula is NaCl. So chemical formula, method of writing is to write the chemical formula, you should know the symbol of the element or radical and the valency of the element and radical. Right? For writing the formula of the magnesium chloride. So they are given an example of magnesium chloride. Okay, let's take over here magnesium chloride. Magnesium is, okay, not written here, but it is Mg2 and chloride is, we know it is 1. So this, when we cross multiply, we get it as Mg1, we will not write Cl2, MgCl2. 1 is understood. If I don't write anything over here, means it is 1. So MgCl2 is the name of the compound. So writing the formula of the magnesium chloride, magnesium Mg2 plus and chlorine is Cl1 minus. So write each of the symbols with its valency. Valency of each symbol is written in the top right corner. This positive ions is written first. Always remember that the positive ion, the ion which is positive, will be written first. I will never write chloride here and Cl here. Always all the names will be such that the metal will be first and the non-metal will be next. So always it will be this way. So in case of textbook, they are given it this way. You already know it this form. So it will be Mg2 plus and this is Cl1 minus. And then you are going to take this 2 over here and this Cl is over here. And that's why it is MgCl2. So it's the same thing. Only thing is that I had written it separately, the valency. It is easier to write because यहाँ पे थोड़ा crossing करना थोड़ा difficult दिखेगा. So anyways, it's one and the same, doesn't matter. You are basically cross multiplying over here. So that's why writing the interchange numbers and hence the formula is MgCl2. So Mg1Cl2, that is nothing but MgCl2, ignoring 1. The next one is we will take is zinc sulphide. it is zinc sulphide. Now zinc is again Zn2 plus, so we write 2 over here. Okay, sulphide we know it is just S2 minus, so it is 2 over here. You cross multiply. Now, so it should be Zn2S2, but if these two are cancelling out, then you can do so. Okay, you should not, in fact, you should not write Zn2 as S2. You will cancel out, you will bring out to the smallest form. Okay, you are going to reduce it to the smallest form. Hence, it will be ZNS will be the answer. It will not be, if I write over here Zn2S2, I am wrong. Okay, the 2 will be equal numbers are going to be ignored. Okay, if it is like 2 over them, we are going to ignore that thing, or we are going to cut it down to the smallest part. Similarly, the next one will be iron 3 sulphide, iron 3 sulfate. Now we know iron 3 is of course Fe, and this is 3, and sulfate is SO4 and it is 2. Now in such cases, what you do is, of course you are going to cross multiply, and when writing this Fe2 is okay, this is not a problem, but SO4, because it is in the form of a radical, so everything needs to be in bracket and there will be 3 over here. So it will be this way, it will be Fe2, SO4, and I will call it as thrice. So this SO4 is 3 times. It is not, if I write only 3 over here without the bracket, it will mean that only O is multiplied by 3. So it will be SO12. No, it is not that way. Even S is 3 times and O is also 12 times. So accordingly, I will write over here Fe2, SO4 thrice. If it is 2 over here, SO4 twice. If it is 4 times over here, no, 4 times होगा नहीं, इसे tetra बोल सकते हैं, tetra. But otherwise 2 अगर रहेगा तो twice, Fe2, SO4 thrice, that is 3. Next example, we'll take it as ammonium carbonate. Let's take the example ammonium carbonate. So ammonium is NH4 1 plus, so 1 over here. Carbonate is CO3 and it's 2 minus, so it's 2 over here. We are going to cross multiply over here, so this will be NH4, 2 आने वाला है, इसलिए इसको ब्रैकेट में डालना पड़ेगा, और 2 डाल, because the radical completely, that will be 2, and then there will be CO3. So NH4 twice CO3. The formula will be written as or spoken as NH4 twice CO3. So that is ammonium carbonate. Got it? So this is how you are going to frame, or you are going to find out how you are going to frame this particular kind of the formulas using the very important radical chart. Now remember that this particular chart will be able to help you to frame only those compounds which are combinations of metals and non-metals. See, you cannot frame carbon dioxide, water, acids with this particular kind of a formula. That you will have to learn separately. Okay? So, when we are talking about any particular salt formation or any particular which has got a metal and a non-metal, then you are going to use this particular method of formation of the chemical formula. And that's why we need to revise certain chemical formulas as a revision, and this is because there are certain gases which can never be available in a atomic form. It will always be in a molecular form, which will be diatomic or triatomic, and that's why they are going to be like, for example, over here, the hydrogen will never be only H. Hydrogen molecule, when I am talking about hydrogen which is going to be used in any equation, so whenever I have got any particular equation where hydrogen is going to be used, then hydrogen ka symbol will not be H, it will be H2. Okay, hydrogen will always be H2, oxygen will always be O2, chlorine will be always Cl2. This is only when they are alone. I'm not talking about HCl. If I say HCl, वो अलग है, वो अकेला नहीं है, हाइड्रोजन अकेला नहीं है, क्लोरीन भी अकेला नहीं है. This is a compound which has been formed. But when it is only hydrogen atom or only hydrogen molecules or only oxygen reacting, like for example hydrogen and oxygen reacting to give me water, I cannot say H plus O giving me H2O. I will have to say H2 plus O2. Okay? Similarly, H2 plus Cl2 will give me HCl. Okay? Whenever I am going to use chlorine as a compound, as a particular substance to be used for reaction, it will always be written as Cl2. Okay, they are all diatomic. So which are the diatomic ones? The first three are hydrogen, nitrogen, oxygen. Normal. Nitrogen and oxygen in the air plus hydrogen. ये तो है ही. और बाकी तीनों halogens. Halogens कौन से होते हैं? Chlorine, bromine, bromine, iodine. क्लोरीन, फ्लोरीन, ब्रोमीन, आयोडीन, ये सभी डायटोमिक है. So that's why hydrogen will always be H2, oxygen will always be O2, nitrogen will always be N2, chlorine will be Cl2, iodine I2, bromine Br2, and F2 is fluorine. So diatomic structures, diatomic molecules में ये 7 elements है. Hydrogen, oxygen, nitrogen, chlorine, bromine, bromine, iodine. That's what they are given over here. Not all of them, but they are given over here. Hydrogen will be H2, nitrogen will be N2, oxygen will be O2, chlorine will be Cl2. The next one is hydrogen chloride is HCl. Hydrogen chloride is HCl. Ammonia is NH3. Now these are something which you need to learn, because these cannot be framed using this table. Hydrogen and chlorine will give you HCl. वो हम लोग कहीं यहाँ से नहीं मिलेगा, because you don't have the radical chart accordingly. Okay, so you will not be able. NH3, but of course you know the valencies of that thing. So accordingly you know that nitrogen का valency 3 है, hydrogen का 1 है, तो NH3 बनेगा. Chlorine का 1 है और hydrogen का 1 है, इसलिए HCl ही बनेगा. So you know that thing, but yeah, it is not directly from the radical chart. But these ones are completely different. They are not all connected even to the valencies. Carbon ka valency 4, oxygen ka valency 2, but still CO is carbon monoxide. That is some unique natures of the gases, that their valencies are not going to be matched at all, because they are going to share the valencies accordingly. So it will be not required to understand how it is being formed. But CO is carbon monoxide. CO2 is carbon dioxide. कितना ऑक्सीजन है उसके हिसाब से उसको मोनो डाई वैसे डालते हैं. CO, O कितना है? एक ही O है, इसीलिए क्या है? मोनोऑक्साइड. अगर 2 ऑक्सीजन है तो डाइऑक्साइड, इट इज कार्बन डाइऑक्साइड. CO2 कार्बन डाइऑक्साइड. NO नाइट्रिक ऑक्साइड. N2O नाइट्रस ऑक्साइड. NO2 नाइट्रोजन डाइऑक्साइड. SO2 सल्फर डाइऑक्साइड. So the names of the acid, which is very, very important to learn. HCl is hydrochloric acid. Nitric acid NO3. NO3, HNO3, nitric acid. See, all acids will definitely have H as the starting point. They all have H. Okay, all acids start with an H. So that's why HCl, hydrochloric acid. HNO3, nitric acid. H2SO4, sulfuric acid. H2CO3, carbonic acid. H3PO4, phosphoric acid. So these are the acids which you will require to learn by heart. Salts, anyway, you can do it from this also. But anyway, the salts which are commonly used are bases में KOH, potassium is K, OH is है, that is 1 है, इसीलिए KOH. NaOH, Na and OH is sodium hydroxide. Calcium hydroxide, calcium is 2. Okay, I have not written that. Calcium is 2 and hydroxide is 1. That is why CaOH twice. Copper sulfate, CuSO4. Sodium chloride, NaCl. Potassium nitrate, KNO3. Now metallic oxides of divalent metals, Ca with a valency 2 and oxygen 2. That is why it is CaO. calcium oxide. Iron valency 2 and oxygen 2, that's why it is iron 2 oxide, FeO. Copper with valency 2 and oxygen 2, that's why it is copper oxide, copper 2 oxide, CuO. Metallic chlorides of divalent compounds. So consider divalent compounds like that is calcium, iron and copper. So calcium with chlorine will be calcium chloride, CaCl2. Fe2 and chlorine will be FeCl2. Copper and chlorine will be CuCl2. So writing formula of the compound of metals of variable valency will be Cu and O will be Cu2O. If it is CuB2 and OB2, then it will be CuO only because 2 cancel ho jayenge, CuO. If it is Cu and Cl with valence Cu having valency 1, then it will be just CuCl. If Cu has got valency 2, then it will be CuCl2. So depending upon the variable valency, you will be having the different compounds of copper and chlorine. One could be copper 1 chloride, another could be copper 2 chloride. Copper 1 chloride will be CuCl and copper 2 chloride will be CuCl2. Okay, because of the cross multiplication over here, right? So they are given you the complete list of some important formulas over here which you don't need to learn by heart. I would say you don't need to learn this by heart because each and every name can be framed by you. You can easily form like potassium chloride. You know potassium from here and chloride from here, so you know it is KCl. Formation is easy. You don't need to learn by heart. Similarly, potassium hydroxide, K1 plus, OH1 plus, that's why KOH. We'll take one over here, that is potassium zincate. So you know K is 1 plus and zincate is ZnO2 2 plus, 2 minus. So that's why it is K2 ZnO2. So you just can frame this thing. I'll just give you an example of this thing once again, and let's take it as the one as potassium plumbide. Let's take the example of potassium plumbide. Let's see that I have not learned this thing at all. I just know this radical chart. This radical chart I know from the textbook, that is page number 49. And I know that I need to find out the formula for sodium plumbide. Now, based on the radical chart, I know that sodium is Na1 plus and plumbide is PbO2 minus. See this PbO2 2 minus. So once I know this, I just know that this is 1 and this is 2. So cross multiplying it, I get it as Na2 PbO2. So this is nothing but sodium plumbide. Why the other? Na2 PbO2. So you don't need to learn it by heart. If you know the radical chart, you need not learn the complete page number 53. Page number 53 can automatically generated by you by these formulas. You don't need to by heart this thing. अरे copper chloride क्या था? CuCl2 वो करने का जरूरत नहीं है. You know that copper 1 है तो CuCl, copper 2 है तो Cu और Cl1 तो CuCl2. So quite easily done. So there should not be any reason for you to learn the complete page number 53 by just by hearting the different names. So I don't think any of these which are going to be difficult for you to find out how to name them. Only just remember that if both the valencies are same, then they cancel out. So the names are going to be having only without any numbers. So it will be like, suppose if Fe2 and O2, so FeO2 nahi hoga, it will be just FeO. Fe2 O2 nahi hoga, it will be just FeO. So that was about the important chemical formulas which are there on page number 53. You can just go through this thing completely. Okay, no need to by heart this thing. The next what we see is about the chemical equations, but I'll take it in the next video.